Assalamualaikum and a very good day to all students taking this course, which is analytical chemistry. As you know, today we are going to go through chapter 2, which is data handling and method validation. As you know, data handling and method validation is very crucial in any analytical chemistry program. Because of what? Because data handling and method validation, from this you can verify any data that you got, and data is very precise and very can address the issue that you are addressing. So data handling is and method validation is very critical in ethical chemistry. So in data handling, normally you will encounter with these numerous terms such as accuracy, precision, and bias. So when you are handling in data handling, you must take into consideration, okay, the importance of you to determine the accuracy of your data, the precision of your data, and whether the data is biased or not. This is very crucial. As you know, so because of the term is very crucial in chemistry, you must know the precise definition or as the exact definition of accuracy, precision, and also bias. From this diagram, it will elaborate to you more further regarding how accuracy look like and how precision will be and how biased your data can get. Okay, if you wrongly handle or you handle your method in a not a specific manner or not in accordance with the standard specified. So for in terms of accuracy, you must know how close or to your or to the data to the concentration, whereas for the precision is being able to constantly predict the same concentration. So meaning that you must know, yeah, you must be able to predict the data of your data. Okay. At the same time, there's certain bias that normally encounter when you are handling any data. Okay. Bias actually referring to a systematic or common error of reporting a value higher or lower than the true value. So you must remember when you are reporting any value higher or below than the exact value is considered as a bias in regarding the data. Next, okay, this slide further explain to you regarding what accuracy is. Okay, so accuracy can be actually be defined as the degree of agreement between the measure value and the true value. So you have true value, you have the measure value. So meaning that normally the true value is the standard, and the measure value is the value that you get when you conduct a testing or any type of test. Okay, to get the internet data. So you compare it with the true value. So this is the degree of agreement known as accuracy. So an absolute true value is seldom known. So it's no it's because you doesn't know, okay, the absolute true value. Because of what? Because if you already know the true value, okay, you doesn't need to conduct the experiment more. Correct? So that's what, okay, when you conduct any experiment or test, because of what? Because you want to know the exact data of the sample that you are testing. So normally, the residual value is seldom known. Okay, this is basically the basic knowledge of any ethical chemistry. Okay, so a more realistic definition of accuracy then uh, then would assume it to be the agreement between a measured value and the accepted true value. So they further define the accuracy as to be the agreement between the measured value and also the accepted, meaning that there is accepted true value being accepted while only. Okay. For example, you are testing a polymer sample, for example, polypropylene. You already know the accepted true value. However, the polypropylene is being added with additive, so you doesn't know the exact value. So you need conduct test to get the measured value. When you get the measured value, you compare to it to the accepted true value. So this is known as accuracy. Okay, the accuracy to which we know the value of a standard sample is ultimately dependent on some measurement that will have a given limit or certainty in it. Okay, precision. Okay, precision is the degree of agreement between measurement of the same quantity. Okay, that's it. It is the repeatability of the result. The precision may be expressed as the standard deviation the coefficient of variation, and the range of data, or has a confidence level interval, example 95% above about the mean value. Okay, so the good precision does not assure good accuracy, so this must put into consideration. This would be the case, for example, if there was a systematic error in the analysis. Okay, this diagram further elaborate to you regarding the term of good precision, good accuracy, good precision or poor accuracy, and poor precision and poor accuracy. So from this diagram, you know that a good precision, this diagram have a good precision and good accuracy, while this diagram represent to you the good precision but with poor accuracy. Because what? Because it deviate further from the from the accepted true value. Whereas for this diagram, it shows to you the poor precision and poor accuracy because your result is being tabulated very far from the accepted true value. Okay, so when you determine error, okay, you must know that error they are systematic when you are determinate error. Okay, determinate error are those of that, as the name implies, are determinable and are presumably can be either avoided or corrected. So determine error actually when determine an error, you actually already know the error that can occur when conducting a test to get the data, for example. Okay, so it can be avoided, and when it can be avoided, of course, if still the error occur, it can be corrected. Okay, they may be constant, as in the case of uncalibrated pipette that is used in a volume deliveries. This is an example. So, or they may be variable, but to such of nature that they can be accounted for and corrected, such as burette, whose volume reading are in error by the different amount of different volume. So this example show you that the determinate error can be corrected. Okay, determinate or systematic error are non-random and occur when something is intrinsically wrong in the measurement. Instrument, okay, there are common type of determinant error. Okay, being listed here. The first one is instrumental error. Okay, this include faulty equipment such as uncalibrated glassware. Where another type of determinant error is the operative error. Okay, operative error referring to the personal error and can be reduced by experience and care of the analysis in the physical manipulation involved. Okay, so the operative error can be minimized by having a checklist of operation. So when you have a checklist operation, it will minimize the operative error. Operation in which this error may occur include transfer of solution and bumping during sample dissolution, incomplete drying of sample, and so on. So this is example of operative error. Okay, so it already being identified, so it can be minimized. Okay, error of the method. This is another common type of determinate error. These are the most serious error of an analysis. Most of the above error can be minimized or corrected, but for error that are inherent in the method cannot be changed unless the condition of the determination are altered. Okay, so some sources of methodical error include co-precipitation of impurities, slight solubility of precipitate, side reaction, incomplete reaction, and impurities in region. So this type of error it cannot be changed unless the condition of the error is being eliminated. Okay. Okay. This slide further this slide show you another type of error, which is indeterminate error. Okay, as the name implies, it actually referring to a type of error that occur randomly. meaning that compared to determinate error, which is can be predict and corrected, this type of error occur randomly. Okay, indeterminate error often called accidental or random error, which is represent the experimental uncertainty that occur in any measurement. These errors are revealed by a small differences in successive measurement made by the same analysis under virtually identical condition, and they cannot be predicted or estimated. Okay, this accidental error will follow a random distribution. I said, therefore, mathematical law of probability can be implied to arrive at some conclusion regarding the most probable result of a series of measurements. Absolute and relative uncertainty. Okay. Whenever a measurement or result of a calculation is numerically represented, it is implicit that the last digit of the number is uncertain, plus minus 1. Okay, so let's remember about this. Okay, so the uncertainty of a number is often called the absolute uncertainty. Okay, the relative uncertainty is the absolute uncertainty divided by the value of the number. A series of class reading, for example, might be 595.4 millimeters, 595.8 millimeters, 596.0 millimeters, and 566.1 millimeters will have an average of 565.6 millimeter. Okay. We understood that the value can be between 595.5 to 595.7 millimeter. So here the uncertainty of the numbers also called the absolute uncertainty in the tenth digit of 0.1 millimeter. Okay. If we say the distance between Seattle, Washington and Arlington, Texas is 2.99 multiplied by 10 to the power of 3 kilometers, okay, the uncertainty in the is in the 10 digit. Okay, so the absolute uncertainty is 10 kilometers. So this number denote a range of between 2,980 to 3,000 kilometers. Okay, so the relative uncertainty is the absolute uncertainty divide the value by the value of the number. Okay, in the first case it is 0.1 divided with 595.6, or one part of 5,656. So in the second case, it is 10 divided with 2.99 multiplied with the power 10 to the power of 3, or one part of 299. Way of expressing accuracy. Okay. In terms of absolute error, the difference between the value and the measured value with regard to the sign is the absolute error. It is reported in the same unit as the measurement. For example, if an analyst reported 2.62 gram of copper as 2.5 gram, the absolute error is minus 0.11 gram. So if the measured value is the average of the several measurements, the error is called the mean error. Okay, whereas for the relative error, the absolute or the mean error expressed as percentage of the true value is the relative error. Okay, so the above analysis has a relative error of minus 0.11 divided by 2.62 multiplied by 100% is equal to minus 4.2%. Okay, so the relative accuracy is the measured value of the mean expressed as percentage of the true value. So the above analysis has a relative accuracy of 2.51 divided with 2.62 multiplied with 100% is equal to 95.8%. So relative error can be expressed in unit other than percentage. In the very accurate world, we are usually dealing with the relative error of much less than 1%, and it is converted to it is convenient to use a smaller unit. Okay, A 1% error is equivalent to 1 part in 100. It's also equivalent to 10 part in 1000. Okay, so that you co- this is uh, type of assessment that it could be conducted. So question one, the result of an analysis are 36.97 gram compare with the accepted value of 367.006 gram. So what is the relative error in part per thousand? Okay, so this is assessment that we conducted. So and the answer is absolute error equal to 36.97 gram minus 37.06 gram is equal to minus 0.09 gram. Relative error equal to minus 0.06 divided with 37.06 multiplied by 100 1000, okay, is equal to negative 2.4 per thousand. Okay, percentage here indicate part per thousand just as percentage indicate for the part per hundred. Validation of analytical method. Okay, okay. There is the two type of validation. Okay, which is, the first one you need identify first the problem and the method it perform. Okay, definition. Validation is the process of documenting or proving that ethical method provided ethical data acceptable for the intended use. So you must know that data you correct is accurate. Data you correct is being verified. So that is known as validation ethical method. Okay, the basic concept in first one is that the problem and the data requirement. So any technical data, you must know the problem and what data you are intended to get. Okay. And the second one is the method and its perform performance characteristic. So when you know the data to be for what, you know the method to be carried out, and you must know, okay, you might can be able to predict the performance characteristic of the test that being going to be conducted. Okay, so the ethical process benefit when the analyst can be involved in defining the problem. That is making sure the question are posed. Okay, when data requirements are poorly conceived or unrealistic, analytical measurement can be unnecessarily expensive if the method selected is more accurate than needed, or it may be inadequate if the method is less accurate than required, or of questionable value if the accuracy of the method is unknown. So this is much more catastrophic. Hierarchy of analytical method. Okay, the first one is the technique. Technique is the scientific principle useful for the providing compositional information. Example, spectroscopy. Once you know the technique, then you will know you go through the method. So the method is the distinct adaptation of a technique for a selected measurement purpose. For example, para para pararoaniline method for measurement of sulfur dioxide. So when you know method, you can further dive into the procedure. Procedure is a written direction necessary to be used to use a method. So for example, the type of procedure is the ASTM, American Standard Testing Method D2914, which is standard test method for the sulfur dioxide content of the atmosphere. Okay, then once you know the procedure, you further dive into the protocol set of definitive direction that must be followed. It must be followed, without exception if the ethical results are to be accepted for a given purpose. So, for example, EPA reference method for the emission of sulfur dioxide in atmosphere. Okay, pararoaniline method. Okay, so this protocol. So the hierarchy of ethical method it is analogous to a pilot checklist for each stage of flight. Okay, such as least reduce the likelihood of landing with landing gear retracted. Similarly, an analytical protocol checklist reduce the likelihood that the pH will be inappropriate or a step omitted. Okay, If the procedure has been validated, then going straight through the according to instruction, making all the measurement in order should give you the reliable result that you want. Okay. Further, if there is problem, the specific that what caused the problem can be the evident. Validation process. Okay. The need to validate a method and the procedure to be followed are matters of profession judgment. Very well prescribed procedure and guidelines are now available that aid in decision making. Government and international agencies have issued guidelines for appropriate method validation, particularly for method for regulatory submission. Generally, they include studies such as selectivity, linearity, accuracy, precision, sensitivity, range, limit detection, limit of quantitation, and also ruggedness of robustness. Okay, this is the general process of evaluation and validation of methodology. SRM did actually denote to the standard reference materials. Okay, selectivity. Okay, selectivity is the extent that which the method can be measured the light of interest in the matrix or the sample be analyzed without interference from the metric. Okay, metric effect may be either positive or negative. Okay, so the analytical response to the light in the presence of potential sample component is compared with the response to a solution containing only a analyte. Okay, so the selection of an appropriate measurement methodology is the key consideration. Okay, method even previously validated in general term may be assumed to be validated or particular sample metric. The metric is everything in the sample except the actual analyte of interest. A component in the metric can interfere with the definition of analyte. Example, induce a metric effects. Linearity. A linearity study verifies that the response is nearly proportional to the analyte concentration uh, in the range of the sample solution. Okay, so the study should be performed using standard solution at live concentration level in the range of 50 to 150, okay, of the target and light concentration. 5 concentration level should be allowed detection of the curvature on the calibration curve. Okay, each standard should be measured at least 3 times. Linearity data of often judged from the coefficient of determination and the intercept of the linear regression line. At R2 value of bigger than 0.998 is considered as evidence of acceptable fit the data to the regression line. Okay, the y-intercept should be small percentage. The unlike target concentration, for example, below than 2%. While these statistical evaluation are practical way to assess linearity, they do not guarantee it should always be show inspection of the calibration curve. Okay, the linearity will often deviate somehow at high or low value. Okay, so this is the reason okay, least square plots may be preferred. In one mode of weighted least square, the point with the least relative deviation are given more weight in the regression line. One way of evaluating the range of linearity is to plot the response factor or RF versus concentration. Okay, so this is the response factor. Okay, this is the response factor versus the concentration. The y-intercept value is subtracted from the corresponding fluorescent intensity for each concentration, which is 0.1, 0.2, 0.4, and 0.8, and divided by each concentration. Okay, such a plot has been referred to as Cassidy plot. Okay, okay, so the slope of the line is minus 1.48 response factor over 1 ppm. But per million. Okay, this corresponds to minus 1.0 over the confidence range from 0.1 to 0.8. Okay, which is 1.8% of the average RF value of 5.45. This is acceptable linearity. Accuracy. Accuracy of a method is the closeness of the obtained value to the true value of the sample. This is probably the most difficult parameter to validate. Okay, one should should consider the sample and the sample treatment in addition to the measurement method accuracy. Accuracy of the method can be determined in one of the three ways. The first one is the analysis of a reference material, comparison with result using another method known to accurate, and also recovery study. Okay, so A is more preferred. If one can't do A, then B is second choice and C is third. So you must remember this is the sequence. If you cannot do A, you proceed with B. If you cannot do B, you proceed with C to validate your accuracy. Okay. Recovery study are performed by spiking or adding a known amount of analyte either to a blank matrix, a sample that has a measurement label of the test analyte, or by spiking a sample which the background analyte is measured by the same procedure and subtracting the total sample plus spike value to obtain the recovery. So the spike sample should be prepared at the three level, the extreme and the mid range. Okay, they should be prepared at least in triplicate. So it must be conducted three times. A good spike recovery, okay, cannot, however, ensure a lack of positive interference. A better validation method is to perform the analysis by two independent methods, in which the second method is the procedure known to be accurate for the sample metric of interest. Ideally, okay, even the sample treatment should be different. You can often find in specific literature, in journal, different book or standard method, a method that is acceptable to your sample, but they may not be appropriate to use because of expense, unavailability of the equipment, and etc. factor. If none can be found that has been applied to your sample metric, but one is known to be generally applicable and accurate, then use it. Okay. If result of your method and the second method agree, there is good evidence they both work for your sample. Okay. If there is a disagreement, then it is not possible to draw any conclusion, since either may give erroneous result with your particular sample, although it's probably most likely your method is the culprit. So, the ideal way to validate a method is to analyze a reference material identical in composition to your sample. So, the National Institute of Standard or NIST has a goal of ensuring accurate and compatible measurement to the development, certification, and distribution of standard reference material or SRM. Okay. The SRM program has over 1,000 SRM standard reference materials available for use in basic measurement in science and methodology. Okay, which is the science of measurement, environmental analysis, health measurement, and also the industrial material and used for production. The NIST has standard for chemical composition, physical properties, engineering material, and the like. Okay, it can be accessed using this link. Okay. So it serves as the main contact point for interfacing with similar effort in the private sector, other federal agencies, and also internationally to cross-check the accuracy of your data. So, the precision of analytical method is obtained from the multiple analysis of homogeneous sample. You can determine the overall precision of the method, including sample preparation. Such precipitation data are obtained by on one laboratory one day. Okay, using adequate of the homogeneous sample that have been independently prepared. Such intra-laboratory precision is called repeatability. Okay, so interlaboratory precision, if appropriate, is also determined as part of the measurement of reproducibility or robustness of the method. So you can also determine the precision of the different step of analysis. For example, the precision of injecting a sample into a gas chromatograph determined from the multiple injection of the gas same sample. Yeah. Okay. So again, statistical consideration dictate that at least 7 measurements should be made for each evaluation step. Sensitivity. Okay. So the sensitivity is determined by the slope of calibration curve and generally reflect the ability to distinguish two different concentration. Okay. So you can measure the slope or measure sample of closely related concentration at high, intermediate, and also low concentration. So the intense sensitivity and precision will govern how many significant figures should be reported in a measurement. Do not report 11.25% when a method can at most distinguish 0.1% 0.1% difference. Sensitivity is often confused with a limit of detection. Okay, range. The working range of a method is the concentration range over which acceptable accuracy and precision are obtained. Okay, usually it's also linearity. Okay, the acceptable accuracy and precision are generally specified in establishing method. Okay, the precision will of course vary with the concentration, becoming poorer at low concentration, such as shown in this figure, as well as sometimes at high concentration. Okay, at high concentration as a as in spectroscopic measurement. Okay, limit of detection LOD and limit of quantification LOQ. Limit of detection, the lowest concentration of substance can be reliably detected in a sample with a certain level of certainty, usually 95%. Typically, okay, a replicate blank of sample metric are analyzed to determine the mean blank value and its standard. Then a metric is spiked with analyzed near the quantification limit. Example, to give a signal 10 times the standard deviation above the blank mean signal. So the limit of detection in the concentration is calculated to give the response equal to the blank signal plus the standard deviation. So the key term used to compare analytical technique, procedure or adjustment. So all the LOD value, okay, may change over time due to improvement in the analytical method. The limit of decision CC alpha is the concentration of the measurement and the significant difference from zero. Limit of decision is equal to S, okay, to the power of 1.65. Okay, the concept is example used when determining whether the material is contaminated or not. Okay, the limit of blank or LOB or critical value is not a concept defined in in VIM3, but has been defined as the highest apparent concentration of a measure expected when replicate of a blank sample containing in the measured. Okay, okay. The limit of detection. Okay, okay. The limit of detection or LOD is the lowest of concentration. Okay, that can be measured at a specific level of confidence. So limit of detection equal to LOD at to the power 3.3. Limit of the detection. The limit of detection is the limit of measurement, system instrument, and the method that should be kept apart. Okay, so detection limit of the measured system is determined by representing the system directly with a region blank. Okay, when the detection limit of the measuring method is determined, the sample is processed to all steps of the Measured procedure. Okay, this is okay, limit of quantification or LOQ. So the limit of LOQ or limit of quantification is not a concept defined in VIM3 but has been defined as the lowest concentration measured and can be determined with an acceptable level of repeatability and also precision. Measuring interval. Okay. Set of quantities of the same kind that can be measured by a given measuring instrument or measuring system with a specific instrumental uncertainty under defined condition. Okay. So the measuring interval is dependent on the extent to which the measuring system can be produce results which are fit for the intended purpose. So the lower limit of the measuring interval coincide with the limit of quantification LOQ, which is the lowest concentration of the measured can be measured, measured with an acceptable uncertainty, which is higher than the detection limit. Okay, so this is guidance showing you the measuring interval. Okay, it shows you the measuring interval and the linear interval. Okay, this is the absorbent value, whereas this is the concentration. Ruggedness or robustness. Okay. Repeatability is a long-term precision over several weeks of analysis conducted in the same laboratory. Ruggedness refers to the precision of one lab over multiple days, which may include multiple analysis, multiple instrumentation, different source of region, different chromatic volume, and the like. So the ruggedness study will identify those factors that will contribute to a variety of results that should be changed. Okay, this is related to robustness or reliability of the method, which refer to how sensitive is to deliberate or uncontrolled small change in the parameters such as size of the sample, the temperature and pH of the solution. It can be also the region of concentration. It can also be time and so forth. Okay. It is include in relation of stability of region, standard and sample with time. Okay. Quality assurance. How do you know that does the method still work? Okay. One method has been validated. An important aspect of applying it to assure that is working properly. So quality assurance or QA is the implementation of procedure to ensure that and document that the method continue to perform as required as in part of responsibility of the quality assurance unit. It include written documentation of variation of method, procedure follow, and the sample custody chain. A number of quality control procedures are implemented based on the quantitative measurement. Okay. Type of quality control QC activities are listed below. Control chart, documenting and achieving and also proficiency testing. Okay. For the proficiency testing, okay. One way of documenting performance of laboratory is to practice in the collaborative interlaboratory studies. Okay. An official body provide adequate of the same homogeneous and material to the laboratory for analysis. So the goal is to compare the result among laboratories and the uncertainty in the result. So the mean result of the participating laboratories can be used as the reference and the actual concentration is not known. Okay. So one way of expressing the result of qualitative testing exercise is to report the laboratory Z score. Okay. As shown in the diagram here. Okay. A measure to show its deviation from the standard deviation of the known concentration. So this is the question 2. Okay, I want you to go to question 2 and then the answer is being shown in the next slide. Go through it so that you have a better understanding. So this question be embedded between the slide to give you better understanding what I am being presenting to you regarding this topic of data handling and data handling and validation. Okay, so when talking about data handling and result validation, The laboratory accreditation is very crucial. So you must know about this information regarding laboratory accreditation so that your data is being certified and it is being also verified so that once you get the data, it can be data that are reliable. Okay, so the key fact in any laboratory accreditation is the accreditation process, and also you must know what type of the accreditation body, whether it is the DSM, Department Standard of Standard Measure, whether it's National Accreditation Body or an NAB. Okay, and then furthermore you must know the accreditation standard. So benefit of accreditation you also must know, because accredited laboratory can improve the accuracy and speed of analysis, reduce error, and improve the efficiency of treatment. So people will have better trust on your laboratory because of what? Because it is being certified by a governed body. Okay, recognition you get also will also get accredited. Okay. Okay, thank you so much for your for listening to my presentation. Okay, that's all. Okay, this is consists of 42 slide. Okay, at the end of this slide, there is a quiz here. I want you to scan this QR code and answer the quiz online. This quiz is being intended, okay, to give you to measure your understanding regarding this topic. So once you completed the test, this quiz, it will be automatically stored in my drive. So I will go to your answers. Okay, this is objective question. Best of luck. I hope you go. If you cannot, if you have any confusion regard to answer this quiz, you can go to back my video and refer it to which part can help you in answering this quiz one, quiz two. Best of luck. Thank you so much for your time and have a pleasant day.